yo, 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 yo. Hey guys. So we're going to talk about more exponents and integer exponents in this video. So if you haven't watched part one, make sure you watch that first. I'm going to assume you've already know all those properties, and we're just going to do some more problems that might, I don't know, just look a little bit different, or kind of go through what order we would do certain things in, and so on and so forth. So this is a list of all the properties that we talked about in the first part. So this is all those key terms. We had examples. These are all the examples with numbers or just with letters showing you the rules. And this is each property. So this is super important. This has every rule that you need to know right here. Now you're going to be doing problems that look like this. So with these types of problems, it's really just doing one step at a time. Like, it looks like there's a lot going on here, but if we take it one step at a time, it's not that bad. So what I mean is, first we got to let's look inside our parentheses. Think about order of operations, PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. So we're actually going to follow our order of operations, and let's work inside these parentheses first, and then let's rewrite everything. So I have 5 minus 2. I can't do this distributive property with this because of this addition and subtraction in between. So really I actually need to do the 5 minus 2, which is 3. So that's 3 to the 5th power times 3 to the negative 8 plus 5 plus 2 is 7 raised to the power of 0. So already we just took this out and rewrote everything. Already it should look a little bit easier, I would hope. Because now I look at, well, anything raised to the power of 0 is 1, so that's just plus 1. And then this is just 3 to the 5th. I actually don't even need these parentheses anymore. Those are not necessary, so let's go ahead and even just erase those and just put the 3 because I don't want to confuse you anymore. That's just 3 to the 5th power. So what I'm doing is it's just 3 to the 5th times 3 to the negative 8th. This is the product of powers. This is when I'm just multiplying two numbers with the same base. I just add the exponents. So I'll go off to the side here. This is just 3 to the power of 5 plus negative 8. Because it's a negative, it doesn't change my process here. I'm still adding the exponents. And that's going to give me 3 to the negative 3rd power plus 1. Now from here, since this is a relatively simple exponent that I can simplify, we know our cubes are perfect cubes based on our square root and cube root notes. 3 to the 3rd power, well, hold on, before I even get to that, I'm sorry. Before I even do that, I realize I have a negative exponent, so now I also have to use my negative exponent property, where I got to bring this down to the denominator. So this is going to become 1 over 3 to the positive 3rd power plus 1. Well, 1 over 3 to the positive 3rd. 3 to the 3rd power is 27. 3 times 3 is 9, times 3 is 27. So that's going to be 1 over 27 plus 1, which is just 1 and 1/27. And I'm done. There's nothing else I need to do. So take it one step at a time and just use all your properties. Let's look at another one. So this one, again, I've got brackets, parentheses, a few things going on. So first, let's just do these parentheses in here first, and then we'll go from there. We'll do these ones in here. So 3 plus 1 is 4. I'm going to keep those in parentheses. I'm going to put the square on the outside, and then I'll even do the brackets still. Seven minus 3 is 4 squared. Now, all these parentheses and brackets make it look somewhat confusing, but there's nothing happening in these parentheses, and this is just being raised to the 2nd power. So this is just 4 squared. So really what this is 4 squared. All of that is raised to the 3rd power over 4 squared. I just got rid of the brackets, pretty much is what I did. Now, before I start worrying about the division, I want to simplify the top first. Simplify my numerator. So I have a power raised to another power. So whenever I have a power raised to another power, I multiply the exponents. 2 times 3 is 6. So that's 4 to the 6th over 4 squared. Then because I'm dividing, quotient of powers when we subtract. And that's 4 to the 4th power. We'll leave it there. Okay. What I want you guys to do is try this one on your own and see how you do. And you know what? Might as well try the second one on your own too. And then, so pause the video, try both of these, and just see how it goes. Okay. So this first one, parentheses first. So this is going to give me 6 minus 1 and 3 plus 2 are both 5. So that's 5 squared, all raised to the second power, all over 5 to the third power. Now I got to do 2 times 2 because this is product of powers. I'm sorry, this is the power of a power. Apologies. That's 5 to the fourth power over 5 to the third power. 4 minus 3 is 1. So that's just 5 to the first power, which is just 5. Now if you wrote 5 to the power of 1, that's fine. This is still the same thing. There's just no reason to write to the power of 1. This is not necessary. Okay, so hopefully you tried this one. If you haven't tried that one yet, you should. You should try it right now. And so pause it again, try it out, see how you do. Okay, so let's go step by step. I have a power raised to a power, so I can go ahead and just take care of that. That's 2 to the 6th. Minus, so I got to do these parentheses. So that's going to give me 4 to the power of 3 times 4 to the power of negative 5. Now from here, what I'm going to do is I'm going to worry about my multiplication because I do my addition and subtraction last. I'm not going to do anything with this. And I can't combine, when we're adding and subtracting, we can't combine exponents. That's when we actually have to evaluate them. I'll show you what I mean by that. So 4 to the third times 4 to the negative 5, this is where we add our exponents. So that's 4 to the negative 2. All I did was 3 plus negative 5 because whenever we're multiplying two numbers with the same base, just add the exponents together. 3 plus negative 5 is negative 2. So I'm left with 2 to the 6th minus 4 to the negative 2. So I'm going to move this up here and just rewrite where we're at just because I have more room up here. 4 to the negative 2. Well, that's 1 over 4 squared. So I got to get rid of that negative. Which is then 4 squared is 16. So I have 2 to the 6 minus 1 over 16. Now from here, I can't go any further. I mean, I'm sorry, I can, but I can't go any further with my exponents. The only way to solve this any further is I would have to actually figure out what 2 to the 6th power is. Luckily with 2's, it's actually not that bad of multiplication, and we can do that because I want to evaluate this all the way. So, because 2 to the 6th power is just 2 times itself 6 times, right? Well, 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16 times 4, which is 64. So what I figured out is that 2 to the 6th power is 64 minus 1/16. And this is going to be our final answer of 63 and 15/16. Okay. Now, if we had not 2 here, if we had a larger number here, I would just say leave it here. And this is okay to leave it here because you can't go any further without evaluating this exponent. Because I can't add and subtract numbers with exponents. There's no properties, there's no rules to do that. So then I would actually have to evaluate the exponents. Okay. That's it, guys. So that's all we have. Things to remember. Parentheses first. Or we can put order of operations, but parentheses first. Okay, so like here I would do my parentheses first, and then also let's write down you cannot add or subtract exponents. What I mean by that is if I had 4 to the 3rd plus 4 squared, this is not 4 to the 5th. Does not work. I would actually have to figure out what 4 to the 3rd is, figure out what 4 squared is, and then I would actually have to add them up. Okay, try these 2 independent practice problems. I hope this video helped, and thank you for watching, guys. Gradius out.